Swashbuckling heroes here. At Georgia Tech. You ready to go in the water?
We're able to set up a course that's realistic in an ocean environment. So we don't have a pool that's pristine and pure. The environment is much closer to something you'd find in the real world. The first step is to go through the validation gate, and then they have to approach an LED beacon, and they actually dock with the beacon and follow a orange pipeline that leads them to two bins, and they'll be dropping markers in these bins that they have to identify. Then they go over to a transponder or pinger that identifies a recovery zone, and prior to surfacing, they're tasked with recovering a treasure, and the treasure is in the form of a PVC configured X, and so they have to pick up the X and then they'll surface in the recovery zone.
You learn stuff here that you never learn in school.
And then it has 2 onboard COM ports, onboard Ethernet, and 2 USB ports.
I've gained so much experience from this. Just like, I mean, I focused on the mechanical aspects, so like just the whole process of going through the design work and then like modeling it and getting feedback from various, professors. I definitely learned so much more from this than like anything else I've done at school so far, I think.
We've got 6 thrusters on this machine.
Increase the runtime and increase the uptime of the vehicle.
It really takes multidisciplinary teams to be out here to compete. Some teams are even able to bring in people who are working on an MBA or people who are working in computer graphics who stand up better websites for them.
The biggest issue is how to transition.
The diversity of the individuals that come here add a lot of value to the technology and us understanding what we may not think about from our vantage point. So the diversity of the students and the academia is really important.
Thrusters are 24-volt thrusters, but we run them off these 9-volt batteries.
We talked about we need to think outside the box. These folks are doing it every day.
We need to build a new transmission. Hurry, get rubber bands.
So almost everything on this board is built out of free samples from analog devices and microchip.
Our design is very light considering what we built it out of. We actually used a car bumper. It's a very light sub and very fast.
Then we also have an expansion connector on our board, which allows us to chain on as many other control chips as we want.
We've got some new cameras, new camera housings, some much improved vision capabilities on this platform.
The systems engineering part of it, integrating a bunch of systems together to make them work together is probably the biggest thing. I'm part of the software team, so I have to make sure the mission will run autonomously.
Did you get much sleep last night with it?
About a good 3 hours.
It's all the little things that'll get you, right? Like, you miss a negative sign here, or you have a loose connection here, and some of those things can eat up an entire day.
It worked yesterday!
I saw one team at the pool. They were there all night. And they were there when I went to sleep, and then they were there when I woke up.
Still going.
I love doing design work because this was an entirely new vehicle this year. So in the early processes, I was able to actually have some input into the design, and later on working on the design of things like the charging station, battery pods, sort of the system of the vehicle as well, which was pretty neat.
Watertight is the first thing you gotta have.
We just experienced our first leak ever. We've been in the water for hours and we just put it in with all electronics and water collected in a huge puddle on the bottom. Luckily we were able to save it before any of it got to the electronics. All our electronics are up top, so we were saved.
What we were impressed with is the homeschooled high school team, the Smurf team. They were working with almost a Tupperware box, and we saw them on the dock open that thing 20 times or more each time they made a run, and it stayed completely watertight. We've got other people that had, $10,000 of acrylic design and seals, and they fry.
We had an unknown issue with the submarine. It just sank at the bottom of the pool.
It's a lot of systems that all got to work, and did you come prepared for them to fail? Everybody has ones that fail.
We have all this computational horsepower, and what's killing us is a cheap $100 sensor.
Every time you have everything up and running, and then all of a sudden it's just not.
That's got to be frustrating.
Extremely intense.
It's technology. It has a habit of just doing what it wants.
Oh, come on, no.
Oh, I don't know. That's not.
Go, 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 come on, go!
Oh.
Come on.
Okay, don't run it too many times, dude.
3 minutes, 30 seconds remaining of competition time. That is the end of the qualifying round. There will be 7 teams in the finals.
A little bit of pressure, huh?
Just a little bit. We're ready to go.
Good.
We haven't really changed that much, so we'll see how it turns out.
Just wanted to let you know the finals are now starting, so you might collect around the edge of the water and watch the finals.
Nice to spend a full year working on something like this, to have your efforts really validated. It feels really good.
5, 4,